Ibuprofen by Alexis Bond, Sydney Borden, and Alexis Knowles. The IUPAC name for ibuprofen is 2,4,2-methylpropylphenylpropanic acid, and the chemical formula is C13H18O2. The compound is optically active, and it has both R and S isomers. The S isomer is more biologically active. There are close to 100 isomers for ibuprofen. The 5 most common are listed here. In this molecule, the single bonded carbons are all alkanes. The double bonds inside the cyclostructure are alkenes. A carboxylic acid is located on the other side of the molecule with a double bonded oxygen to a carbon with an alcohol. All of the carbons in the structure, excluding the cyclohexene, are 109.5 degrees. The carbons inside of the cyclohexene are 120 degrees. The double bonded carbon to oxygen is also 120 degrees, resulting in an sp2 hybridization. The double bonded oxygen is 180 degrees, resulting in an sp hybridization. The oxygen bonded to the hydrogen is 107.5 degrees, resulting in an sp3 hybridization. The boiling point for ibuprofen is 157 degrees Celsius. The melting point of the compound is between 75 and 78 degrees Celsius.
Ibuprofen is a very common over-the-counter drug used by many people. It is a painkiller and is prescribed in higher doses to relieve inflammation, swelling, and stiffness, and is also effective in reducing fever. Ibuprofen does not cure the underlying condition responsible for pain, fever, or inflammation, but it does help to keep the symptoms under control.
Learning about the chemical properties and the uses of ibuprofen, we conducted an experiment ourselves to test some of the properties. For example, ibuprofen is soluble in organic compounds, meaning compounds that contain carbon. However, ibuprofen is insoluble in inorganic compounds, such as water. Therefore, we conducted our own experiment to see what would happen when we placed an ibuprofen capsule in 6 ounces of water. Here's a picture of the ibuprofen tablet when we initially placed it into a cup with 6 ounces of water. After 5 minutes had elapsed, you can see that the red coat slowly started to dissolve. After 10 minutes, the red coat on the outside of the ibuprofen tablet had almost completely come off, leaving a white tablet. After 15 minutes, the tablet was completely white. At 20 minutes, the tablet started to break down, forming a powder. At 25 minutes, the tablet had broken into smaller pieces, forming a powder but not dissolving in the water. From our research, we learned that ibuprofen was insoluble in water, but soluble in alcohols and other organic compounds. We wanted to see this property in action, which is why we chose to run the experiment by putting an ibuprofen tablet in water. From our research, we also learned why ibuprofen was more soluble in organic compounds such as alcohols, but insoluble in inorganic compounds such as water. Ibuprofen has a polar carboxyl group, which is the O double bonded to a carbon, which is also bonded to an alcohol, an OH function group. However, the nonpolar alkyl groups in benzene ring significantly reduce the polarity because they are nonpolar. So, ibuprofen, therefore, is fairly nonpolar and cannot be dissolved in water, which is polar.
Getting ibuprofen, when you gonna kick in? Ibuprofen, when you gonna kick in? Ibuprofen, when you gonna kick in?